This is just a collection of miscellaneous board, loose circuit boards and little projects that I've built over the years, starting as a child, kind of on the bottom here, and then moving up to more and more contemporary projects that I've worked on, and I guess they're kind of mixed in between. But you know, I did not know where to store these things, and my parents had given them all back to me when they moved. So I bolted them all, each one, to this this polycarbonate here panel from McMaster Carr. Actually, two panels. The panels are glued and bolted together, glued and screwed together. And then I attached everything, and then I made everything work, so absolutely everything powers up. I had to fix a bunch of circuits, but everything here works, except for the motorized things. They're not hooked up, but all the other things that light up and blink and whatnot, they're all restored and functioning, at least lighting up, so that they can be displayed. I'm prototyping the clock right here. So I've got I'm going to run two types of clocks, this battery one and a GPS clock. And all this through Arduino Mega and some displays. The GPS is sensitive only when you use the external active antenna. Then I can pick up the GPS through my basement window, which is how I'll be operating. So this is actually really sensitive with the external antenna. And it's active right now. You can see the blinking. So we're gonna write some software here. I've set up a series of 8-bit ports to randomly blink or turn on and off the lights on the panel of stuff over there. So we'll stub out the software on this thing. So incrementally moving the clock forward here. Again, we are on GPS time, and I've added a GPS lock indicator so that when the GPS is locked, this will blink. These are the same switches that they used in the Apollo program, the same type, and they're fairly popular. I have some, I've always had a bunch of these in my collection, so I think I'll use one for this and maybe make a label that says GPS lock. So you can see if we unhook the coax for the GPS and it loses lock, wait a sec, it'll stop. So we've lost GPS lock, and then let's see if I can do this one hand, the coax back on. Oh, here we go. We already have lock again. Yep, there we go. So that's pretty sweet. I want to indicate when we actually lose lock. When we lose lock, the program automatically goes right back to this little DS 1302 module. So it doesn't have to have lock to display the date and time. And the plan is to display UTC, local, and the date. And then these are the random blinking lights. There's only 2 implemented right now, but we'll have 3 ports worth firing a random number to these so that we can randomly turn on and off all the other stuff. So yeah, this is pretty cool. Use this old case here, and we're going to do some machining or other drilling operations on it. Okay, so we're working on the enclosure here. Essentially, this old thing that I built when I was a child, like a kid, 13 years old, something like that, will house all of the displays, the Apollo light era light indicator, emission control light thing. So I'm just doing the sheet metal work. Put some brackets on here. These actually came from the deuterium array at Haystack Observatory at MIT. Years ago, I got some old pieces, and I'm still putting the deuterium array parts to work. And then these, I scribed all of this and measured it out, punched it out, and the displays will fit here. So the next thing we're going to do is use a nibbler tool to cut these things out. Here's the L-band SMA, and then of course the Arduino will be on top right there. So there's a lot more work to do. One handy tool for this kind of work is this thing, this optical center punch. They're wonderful. Allows you to do very precise work without a milling machine. More soon. Okay, so I tried a couple of methods. First I drilled 1/4-inch holes and then tried to use this thing to cut, but these things, I couldn't really figure out how to use that, so instead I used these from Midwest Tool to cut an opening, and from there this tool, which is fantastic. These are really good. So this is cutting it nicely. So we'll keep going, see if I can cut these openings precisely enough. Okay, here's some progress. Basically drill a pilot hole, cut it with these Midwest tin snips, which these are the best ones. There's two types. There's a right cutting and a left cutting. I believe these are the right cutting. And maybe I'm wrong, I don't know, but drill hole, cut this out a little bit, and then jam this thing in there and just start munching away. The profile, this is the first one I did. It's a little rough compared to the second one's a little smoother. This will be covered by the bezel for the light, so you won't even notice that one. These ones, we're gonna see what they look like. I think when I paint them, it'll fill in some of this stuff, so we'll just have to test fit everything, see what that looks like, see if it needs any fill. Okay, here's the fit check. This all came together nicely, and there's plenty of clearance. If I pull this out, you can see how we've got the L-band connector, we've got the displays, gave ourselves enough clearance for the Arduino Mega, and it all just kind of fits right in as it should. Had some issues with this L bracket back here. We're gonna have to address that. But looking like we've got tons of clearance, and this thing is nice. I put a little bit of JB weld up here to try to fill the gap. That display had too much of a gap. It was the first one I had cut out with a little nibbler tool. So I think that once we spray it black, that will not be noticeable. These are some of the extra holes that my scrap metal often has, and when we spray it black, you will not see any of that stuff. It'll just be painted right over. Yeah, this looks pretty nice. And here's how it looks, just mocked up and amongst everything else, so should be really interesting. And paint this black to contrast it with everything. Okay, here we go. The I/O board is complete with 22 MOSFETs for driving all the lights and things. Had to remove this USB connector. I'm going to try to extend it out here with something, with some hookup wire, and see if the port will still work. But yeah, all this stuff looks kind of messy, but actually it's not. It's very tight. And it's heavy with all those FETs. Some more. Here's the back of it. These are all pull-down resistors on the gates of the FETs to keep them from floating when the device boots up in its tri-state, or if there's a software error. You don't want these floating, because then they'll start getting hot, potentially, because the solder flux will be enough to bias them up. So these are all pull-downs. This is the main ground, and nothing really draws too much current on this project, so should work out okay. And then all the drains are connected to these screw terminals, so I can screw it all in and not need to solder a bunch of stuff. Although the PWMs up here are 1K and a 1 microfarad cap, which should give me a roll off of about 150 hertz. The PWM, I believe, is 500 hertz, so that should give me smooth voltage to drive some bar graph displays for fun. So those are right there with some little eye hooks to solder to. And we're about to try reworking this with some extension wire and see if it still boots up and can communicate with my computer. Okay, so I did succeed in making my sketchy USB port extension. So here's how it was done. This works. It's kind of ugly, but works just fine, actually. I filled in a lot of extra solder, that's why you see it blobbing out. So anyway, we'll demonstrate it working. Watch this. Let's load the clock program and you'll see it transferring over in a second or two. It's compiling. There we go. No problem, huh? So this is going to be just fine. So time to try the the board that I built. Okay, so now modified the bottom of this thing to accommodate the USB port extension. Put some industrial hot glue on there, and that thing is pretty solid. So time to put the rest of this together and test it. Okay, I've completed the machining and most of the installation for the displays, so it's looking pretty good. And paint, it's not perfect, it almost never is on these things, but it won't be noticed in the end. So now I'm just fitting everything up, cramming the electronics into place. It'll fit, it's going to be a tight fit. But, see the fasteners, spacers, everything in place. So time for some wiring. Okay, here's the panel undergoing a test, and everything except for this is wired up into the panel. There's the real-time clock, there's the GPS clock. So all this is in place. So it's good to test everything we can. And then we'll go do some more. Okay, now we're running off external power supplies. So I've got the external 5 volts running the display and the GPS. External 7.5 or so running this Arduino board. And then this guy's running off an external 24, which is working pretty good. So the next step is to start to put more of this stuff together. Time to do final assembly and then try it again. So here we go. We've got the GPS clock fully assembled, and this is indicating GPS lock. There's no labels on it yet. But, here is the back. And there's a few extra wires hanging off, but everything's been dressed very tightly. So
whenever there's a hedgehog, there's
so we've got the power. These are the I/O, and then you can see the displays underneath there. There's our indicator switch. So the extra 5-volt lines at the top probably end up trimming those off to get out of the way, because we don't need them. And we're going to run this a little bit and see if there's any thermal issues with the clock itself, anything getting too warm inside. Here it is, the chime is completing its sequence. And here's the clock with GPS lock. And there's all the power, and then the random lights, just simulating all the lights going. So everything is working now, and I can also program it with the programmer as well. So next step is going to be to get this ready for mounting and then get the power supply prepped. Okay, so now we've got the clock set up here. We already tested that all works. And then here's the control panel for it. So this will be all lamps on, and it looks just like the I tried to make a layout very similar to what I had when I was young. Yeah, it looks just like what it did before when I was young and started building stuff. So we've got all the lamps on. These are the chimes, the 2 different chimes. This is daylight savings time, a random switch to turn on an electric motor, and these two are to test the chimes. So we'll run it like this. And up back, here's the electrical, the power converters, and some terminal strips. We're going to see about maybe letting the plate be the ground, just sit everything on ground, which can be done with these terminal strips. And yeah, we'll give it a go. Start wiring up the power stuff, and then once that's wired up, we'll test the outputs, and we'll check it with this. Okay, I've now got the power panel here, the control panel, for running the clock, and then I found this power supply, 12 volt, 5 amp, which should be perfect for this. Here's the complete power panel. The labels are not on it yet, but here's the back side. It's actually neater than it seems, but these are the digital I/O and the various powered leads coming off, and you can see the modules, and I dressed this cable. Once you kind of get these out of the way, it's actually fairly organized. These are the little debounce, some first order debounce circuitry. And yeah, everything's on here. The modules are bolted to the plate, so if for some reason those get warm, we'll get the heat off. So next thing is to move this over to the system itself. So we'll install it all right here, and we'll give it another try. Okay, I've got the case mounted in there, and now we'll start to snake the wires in for final install. Okay, we're beginning to get this thing put together here. So here's the first power up. So you can turn on time circuits on. And it's doing its thing. I should start ticking in a minute or so. few seconds. Here we go. Sweet. Had to clean this switch out with some carpet cleaner and sandpaper, and now it's this thing's well over 100 years old, this switch. So now we're good. Now we'll keep on putting it together. Okay, we can already see the action of this clock here. Some of the indicators, and they're randomly turning on and off. There's that one. So there'll be more, but it is according to every second. And the patterns will always be different. Okay, we'll keep wiring more stuff. Here's an update. I'm starting to wire in everything now that all the cables are, all the circuits are working. And so we can see here all the MOSFETs, and there's the screw terminals, and we pull these all to ground. And then I've got the power supplies here. So these are all working out great. So I'll keep wiring, and I'll give another update in a few minutes what it looks like. Okay, so here's the clock running. We have GPS lock over here. Down here is the main control panel. I haven't labeled it yet, but these turn the chimes on. This is the hour Morse code chime. This one is the master alarm 30-minute chime. This is daylight savings time, standard time. So right now we're in daylight savings time. Main fuse, main power. This one's lamp test, so if I put this up, all of the lights will turn on. If I turn it down off, then they go into random mode again. So we can see different things happening here. There's life everywhere in the panel. And here are the chime tests to make sure they work. So this one, when you push one, it turns off all the lights. So here's the beep. You can see that works. And then this is the one that's master alarm. And that's up there on the right. It turns off everything so you can get a more bit more of a contrast. And main power is actually right here. So here's my USB cord right there for updating software. Main power is right here. So off. And then we turn the system on, time circuits on, and then everything comes up pretty quickly. We have GPS lock. I haven't labeled everything yet. This just randomly comes on and off. You can disable it that way. Yeah, there's lots of stuff here. And yeah, these are boards I've made over the years. I have no other place to go, so I figured I'd turn it into a clock. All right, lots of interesting troubleshooting to make this work. Managing the grounds. You really want the low current ground for all the FET and MOSs to be tied directly to the panel. I made this whole panel ground, So it's this panel is a nice low impedance ground. So that goes, FETs go here. Separate from that, the Arduino goes here, and then the local 5 volts for the GPS and these displays are on here, which is tied here. So somewhat of a star-ish ground. You just don't want the high current stuff like this light to jostle the 5 volt rail in any way, or else errors will start to pop up on these displays here, and things will get reset. Because this whole system pulls about 2.8 amps with everything on, which isn't that much, but still a lot of light. Mostly the bulbs are the biggest contributors to that. There's a whole bunch of light bulbs everywhere. These two things are light bulbs. That's a light bulb. This is it's 1 amp light bulb. Smaller one. Yeah, so it's looking good. And I think special attention should be called to these bar graph displays. So there's the 10-digit one. It's beautiful. These are tied to the PWM output pins with a little low-pass filter, so they move around in time, and they look really cool. They just randomly move up and down. Okay, so I found a good power supply here that can carry the current of the system. I've been testing it, it's good. I also found a method to run the motor over here without causing problems with the power supply by having two 10-watt resistors in parallel. Based on the motor current draw, that should only be 5 watts of heat that I'll put into this plate. Another thing I'm doing is doing an inspection with a borescope of the insides to make sure that the cables are all feeding nicely as expected. And they are. Actually, there's the ground bug. Everything is looking good where I want to inspect, so it's a little tight, but it all looks good, so we'll keep going. Alright, so I just fixed one of the features I really wanted on this thing. I really wanted this old motor spinning when you push a button, and previously I put these resistors to reduce the current. The motor's only 1.5 amps, so this really brought the power down. And now I put this these diodes. So these keep the motor current from spiking back into the system. So this one's going to ground. That's the reverse current. And that actually goes from the resistor, where the resistors meet, to the plus rail. So both resistors suppress any high voltage transients from the switch opening up. Because what happens is, when you have a motor, and you push the button, when you open the switch, it's when it opens that there's a huge transient that will mess up your system. So the good news is now we can run all of the features on this system without a hiccup on the display, resetting and messing all that stuff up. So that was a big one. So I think that might be everything. So hopefully, oops, this should be on. Hopefully we can case it back up and start labeling. Okay, we just dealt with another glitch here, which was the wire for the beep test was broke again. So I put a different one on. All of the harnesses are addressed actually quite well, but still using these Arduino jumper things, they can be made of really poor quality material sometimes, so that was the problem actually. Yep, everything's looking good. And now it's time to put the labels on the clock. All right, check out the labels here. Those are some proper Dymo labels. I bought this broken vintage label maker and fixed it from eBay, and these things turned out great. And so next we'll finish labeling the clock part. Okay, here's the system. Everything is complete now, and there's the timing panel, control panel, and push this button, that will go. Here's the daylight savings time switch. These control the chimes. We want to do Morse code every hour and make the buzzy noise every hour. And then here's this lamp test. We'll turn on everything, so you can check to see everything. If you turn off lamp test, it goes to random mode, as everything will randomly. If you turn on lamp test, everything comes on. So that's the lamp test function. Here's the buzzing master alarm. This sounds, that old circuit board there I built, that is a Viswar protection circuit for a radio transceiver I built many years ago. And here's the beep right there. And notice when you do beep or alarm anything, all the lights turn off and they're back to random. And so it has lots of interesting features from different angles. You can see there's kind of like electrical life teeming everywhere. So that was the idea here, was to find a cool way of displaying all this old stuff built over the years. And this turned out, these two things turned out really well. And these are the embossed Dymo labels. Oh yeah, check this out. Here's the power switch. So to turn it off, yep, turn on. Here we go. Yeah, it's looking really good.